What's up, Algebra 2? We are starting section 5.2, properties of rational exponents and radicals. So the first thing says work with a partner. If we are remote, that's a little difficult to do. If you are in person and would like to work with a partner, please feel free. But what I want you to do is actually pause the video. And I want you to fill out the blanks. And then you can try matching. Please don't draw all those lines. Just put maybe like an A or a, C outside of here, or either way. Please don't draw the lines because you can't tell what's going on. But pause the video and take a moment to see if you can fill out the blanks correctly and guess the property. If you get it wrong, that's okay. You can just erase it and change it. Okay, hopefully you filled all these out. I'm going to go over the answers, see how you did. Question A to the negative 2 is the same thing as 1 over a to the second. And that is negative exponent, D. Question B is AB to the fourth. Well, we're going to have A to the fourth and B to the fourth. This is a power of a product. So we start with a product and we do a power to it. Power of a product. Power of a product is C. Now, I don't have an answer key. I'm doing these like by what I think is correct. So hopefully I don't make any mistakes, right? Let's see. The next one, we've got A to the third and then that to the fourth power. We're going to multiply those together, A to the 12th. This is power to a power, or power of a power. So that one is B. Okay, we are multiplying like bases, which means we add the exponents. We get A to the 7th. This is product of powers, I believe. The product of powers, A. Because we're multiplying together two separate powers. All right. A divided by B to the third power is the same thing as A to the third over B to the third. And that is the power of a quotient, which is G. The next one is we are dividing like bases. We're dividing, so we subtract the exponents, A to the fourth, and that is a quotient of powers. And then A to the 0 is 1, and that is 0 exponent E. How'd you do? All right, today, here is a summation of all of the properties that we've been talking about, and each of these examples uses rational. Oh, shoot. Now I can't spell. Rational exponents, which means we've got fractions for exponents, and lots of different examples of what you would do when you've got fraction exponents. All right, so we are going to use the properties above to simplify each of these expressions. Now it says work with a partner. I can be your partner if you want, especially if you are remote today. Okay, the first one, we've got 5 to the 2/3 multiplied by 5 to the 4/3. When we multiply like bases, we add the exponents. So I'm going to be doing 5 to the 2/3 plus 4/3. I'm adding my exponents together. So I get 5 to the 6/3, which is 5 to the second power, which is 25. Question B. 3 to the 1/5 multiplied by 3 to the 4/5. Like bases, So we keep that base and we add the exponents. So we get 3 to the 5/5, which is 3 to the first, which is 3. This is an example of power of power. So we're going to multiply our exponents together. I'm going to put that 3 over 1, so it is a fraction. I'm going to multiply straight across. I get 4 to the 6 over 3, which is 4 to the second, which is 16. This is a power of power. We're going to multiply these exponents together straight across. 10 to the 4 over 2, which is 10 to the 2, which is 100. Here I've got a quotient of powers. So when we are dividing like bases, we write that same base and we subtract the exponents. So we get 8 to the 4/2, which is 8 to the second, which is 64. In question F, we have like bases, so we subtract the exponents. And when I subtract those, I get negative 3/3, which is 7 to the negative 1, which tells me to use the negative exponent rule, which becomes 1 over 7 to the first, which is 1 over 7. All right, now they're going to get a little bit more complicated. As you can see, we've got like bases. So we're going to add the exponents on that like base. But I do not have a common denominator. So we have to add fractions with a common denominator. I'm going to have 7 to the 1/4 plus, now I'm going to take that 1/2 and multiply it by 2 over 2 so that I can get 2/4. Now we have a common denominator. So I get 7 to the 3/4. Does it say what form to put the answer in? Nope. Does not say what form to put the answer in, so I'm just going to leave it in this form. If I needed to change it, it would be the 4th root of 7 to the 3rd. But this one here is the best answer unless it specifies what form you should put it in. All right. For this next question, these are not like bases. So we cannot use our properties. Cannot use our properties because these are not like bases. So instead, I'm going to go on the outside and deal with this power. This is a power of a product. I'm going to do a power to each of these separately. So when we do power to power, we multiply. So I'm going to have 6 to the 2 over 2 multiplied by 4 to the 2 over 3. So I multiplied my 2 by each of those fractions. Now 6 to the 2 over 2 is 6. 4 to the 2 over 3. Well, that we might have to use some skills that we learned in the last section. So I'm going to factor 4. 4 is 2 to the second. Prime factorization. I'm going to keep that 2/3 there. And then what we learned in the last section is you can multiply straight across. We get 6 multiplied by 2 to the 4/3. Well, that didn't totally help either. So let's see if I've got 6 and then I've got the 3rd root of 2 to the 4th. I can separate that 2 to the 4th into 2 to the 3rd multiplied by 2 to the 1st. So I can separate those. So now I'm going to have 6, and we're going to have the 3rd root of 2 to the 3rd, and we're going to have the 3rd root of 2 to the 1st. So now I've kind of broke down that cube root into 2 smaller cube roots by multiplication using one of our properties. I have 6, and then this answer right here is 2 multiplied by the cube root of 2. So I get 12 cube root of 2. Lots of steps there. So this would be a good question to ask about if you need it. All right, next example. These are not like bases. So I'm going to just go to this power and distribute it by multiplying the exponents. I get 4 to the negative 1/5 multiplied, oops, I didn't multiply. One moment. 5/5 multiplied by 3 to the negative 5/5. So now I'm going to simplify, and I get 4 to the negative 1 multiplied by 3 to the negative 1. Now, if they're both negative 1, then we're going to write it as 1 over 4 multiplied by 1 over 3, just 1 over 12. Okay, question D is like bases, and they're quotients, they're dividing like bases. So when we do that, we subtract the exponents. So on top, we have an exponent of 1. On the bottom, we've got 1/3. So to subtract these, we need common denominators. So instead of 1, I'm going to make that 3/3 and then minus the 1/3. So get 5 to the 2/3. And that's as simple as I can go because the power is less than the root. All right, question E. So a couple different orders on which you could do this one. I'm going to start on the inside and see if I can do anything first. So I look on the inside and I see not like bases. So we cannot use the properties. So if we don't have like bases, we can't use the properties. But what I do notice is that they both have a 1/3. So I'm going to be sneaky and manipulative. I'm going to be sneaky and manipulative. I'm going to rewrite this as 42 over 6 to the 1/3 and then squared. So since 42 and 6 both have the 1/3 power, I kind of took it out of both of them and put them in one parenthesis with the 1/3 on the outside. And then from there, they're still squared. And because I did that, 42 over 6 now is just a number, no exponents on it at all. So I can reduce 42 over 6. So 42 over 6 is 7 to the 1/3 and then to the 2. Now from here, I'm going to multiply my exponents together and I get 7 to the 2/3. So I manipulated it. Okay, you'll notice the next section is student practice. This is where you should totally pause it. Try it on your own. That way you can ask questions see if you don't understand something. When I do it, there's a lot of thoughts in my head that you don't see. So I make it look pretty easy sometimes, but you don't know if you can do it till you've tried it on your own. Hopefully you have tried that on your own, and now I'm going to go over the answers. Like bases, we use the property that says add the exponents. The exponents do not have common denominators, so we find a common denominator of 4. And I get 2 to the 5/4. Now, what do the directions say? It just says simplify. I think that this is a good simplification. If we needed to write it as a radical, we would simplify it a little bit differently, but I think this is as far as we're going to go for this one. Okay, we are subtracting the exponents, so 3 to the first minus the 1/4. Need common denominator, so 3 to the 4/4 minus 1/4. So I get 3 to the 3/4. This next one was similar to the example we did above, where I'm going to manipulate it. I'm going to pull that 1/2 out. So I'm going to rewrite this as 20 over 5 to the 1/2, and then that whole thing cubed. And I did that because 20 over 5 is now 4 to the 1/2, and everything cubed. Now remember, four to the 1/2 is the exact same thing as square root of 4. So I can simplify this a little bit further and say that is 2 to the 3rd, because this is the square root of 4, right, which is 2, and then that is 8. So that would be simplest form. Okay, we do not have like bases, so I'm going to take this 3 and distribute it first. Get 5 to the 3/3, multiplied by 7 to the 3/4. So get 5 to the first, multiplied by 7 to the 3/4. This could be one way of writing it as simplest as possible. If you need it in radical form, depends on what the directions say. If you need it in radical form, then you would write it as 5 multiplied by the 4th root of 7 to the 3rd. And that would be fine for the final answer. Okay, the last example is an enrichment for those of us that are planning to go to pre-calc next year. Find the simplified expressions for the perimeter and the area of the figure. All right, perimeter means we add all 3 sides up, but I only have 3 sides. So let's see, you guys, for most of you have taken geometry. And hopefully you remember something called the Pythagorean theorem or Pythagorean triples. So the Pythagorean theorem is a squared plus b squared equals c squared, and the c has to be that hypotenuse. Pythagorean triples would be like a list of 3 sides that are all integers, like 3, 4, 5, 5, 12, 13, 8, 15, 17. Okay. 7, 24, 25, and so on. All of these are triples that will make a right triangle every single time. So we could use two different methods to figure this one out. If you know your triples, you can really figure out the third side very easily. I think I'm going to go the hard way. I'm going to pretend I don't know my triples. And I'm going to use the Pythagorean Theorem to find, and I have no idea, I haven't done this yet, I'm going to find the third side, which we're going to call C, by the Pythagorean Theorem. So the A and the B don't matter which side. So I'm going to do 3x to the 1/3 squared plus 4x to the 1/3 squared equals C squared. So now we have to multiply this out. That's going to be 9x to the 2/3 plus 16x to the 2/3. And we can add those together because they have the same exponent to the same power. So 25x to the 2/3. And then what we have to do is we have to square root both sides. So when we square root both sides, we're going to square root the 25 and we're going to square root the x to the 2/3. So I'm going to start with that square root 25. We should know that that is 5. Now the square root of x to the 2/3, I'm going to rewrite in rational exponent form. So I will get x to the 2/3, and then the square root of that is to the 1/2. Now I'm going to multiply my exponents together, and I get x to the 2/6, and then I'm going to reduce that, so I get x to the 1/3. So 5x to the 1/3 is our hypotenuse. So now the other method is if you noticed the 3 and the 4, and they both had x to the 1/3, x to the 1/3, you could easily just say, well, the third one's going to be 5, x to the 1/3, because that is the rule of the triples. Now we have to find the perimeter. Which we add all the side lengths. So I'm going to take 3x to the 1/3 plus 4x to the 1/3 plus 5x to the 1/3. And our perimeter will be 12x to the 1/3. And do we have any units? Do we have any units? Nope. So just units. So there's our perimeter. And then area of a triangle, you should know, is 1/2 base times height and remember the base and the height have to form a 90-degree between them. So we have to use the two values that make the 90 degrees, which in this case is 1/2 3x to the 1/3 multiplied by 4x to the 1/3. Now, did I put those in the opposite order? Yeah, so you could put these in the other order. I I just wrote them down from memory. I wasn't looking at the picture, but it doesn't matter because you can multiply in any order. So now when we multiply, we'll multiply our numbers. Let's see, 3 times 4 is 12 times 2 is 6. And then remember, when we multiply x to the 1/3 multiplied by x to the 1/3, those are like bases. So we get x to the 2/3. And that would be units squared for area. Okay, that is lesson 6. You can go ahead and work on your worksheet. Remember to ask questions. Have a great day.